Humanity has always looked at the planets and asked the same question: how far away are they? Today, we usually answer that question with numbers. Mercury is about 77 million kilometers away. Mars can be more than 200 million kilometers away. Neptune is billions of kilometers from Earth. Those numbers are accurate, but they don't answer the question most people are actually asking. Because distance isn't the same as travel time. If you boarded the fastest passenger airplane ever built, reaching the moon would take months. At the speed of a Formula One car, it would take decades. Even traveling at the speed of a bullet wouldn't get you there within a human lifetime. Space is simply too large for everyday intuition. And once we leave Earth's neighborhood, the scale becomes even more surprising. Some planets can actually take longer to reach than worlds that are farther away. Others are only accessible during brief launch windows that happen once every couple of years. The route isn't a straight line. The planets never stop moving. And every mission has to work with gravity instead of fighting against it. So when someone asks, how long does it take to reach Jupiter? There isn't just one answer. It depends on the spacecraft, the technology, the mission, and sometimes it depends on where Jupiter happens to be when you launch. By the end of this journey, we'll travel across the entire solar system, from the scorching world of Mercury to the frozen edge where Neptune orbits the Sun. And along the way, you'll discover that the greatest challenge isn't simply reaching another planet. It's understanding just how enormous our own solar system really is. Before we visit a single planet, there's one misconception we need to leave behind. Most people picture space travel as a straight line. A rocket lifts off from Earth, points toward another planet, accelerates through space, and eventually arrives at its destination. It sounds logical, but that's almost never how space missions work. The reason is simple. Nothing in the solar system stands still. Every planet is constantly orbiting the Sun at thousands of kilometers per hour. Earth moves around the Sun at nearly 30 kilometers every second. Mercury travels even faster. Jupiter, despite being much farther away, is still racing through space at around 13 kilometers per second. Sending a spacecraft to another planet isn't like throwing a dart at a stationary target. It's more like trying to intercept a moving object while both of you are traveling around a giant racetrack at different speeds. Engineers don't aim for where a planet is. They aim for where it will be months or even years later. That's why every mission begins long before the rocket leaves the launch pad. Astronomers calculate the positions of the planets years in advance, searching for the most efficient path through the solar system. Sometimes that opportunity only appears once every few years. Miss the launch window, and the mission may have to wait months or even longer for the next chance. Timing is just as important as technology. There's another reason space travel takes so long. Rockets don't carry unlimited fuel. In fact, fuel is one of the greatest limitations of every mission ever launched. If engineers simply pointed a spacecraft directly toward another planet and accelerated the whole way, it would require an impossible amount of propellant. Instead, spacecraft follow carefully designed paths called transfer orbits. Rather than fighting gravity, they use it. The most common route is known as a Hohmann transfer orbit, named after German engineer Walter Hohmann. It's one of the most fuel-efficient ways to travel between two planets. Instead of flying straight across the solar system, the spacecraft follows a long, curved path around the Sun. The journey takes longer, but it saves an enormous amount of energy. In space exploration, efficiency almost always matters more than speed. Gravity itself becomes part of the spacecraft's engine. One of the greatest tricks ever developed in astronautics is the gravity assist. Rather than carrying enough fuel to accelerate forever, a spacecraft can borrow momentum from a planet. As it flies close to a massive world like Jupiter, gravity changes both its speed and direction. To the spacecraft, it's almost like receiving a free boost. The planet loses an incredibly tiny amount of orbital energy, so small that it's impossible to notice. The spacecraft, however, can gain thousands of kilometers per hour without burning additional fuel. Some of humanity's greatest missions relied on this technique. Voyager 1, Voyager 2, Cassini, New Horizons. Without gravity assist, Several of these missions would have been impossible with the technology available at the time. Sometimes, reaching a distant planet means visiting another one first. Even after a spacecraft leaves Earth, its journey is far from predictable. Every mission is a balance between speed, fuel cost, and scientific goals. A spacecraft carrying astronauts might prioritize a faster route to reduce the crew's exposure to cosmic radiation. An unmanned probe can afford to travel longer if it conserves fuel or allows engineers to carry heavier scientific instruments. There is no universal travel time to any planet. The same destination can produce very different answers. Mars provides a perfect example. Some robotic missions have reached it in just over 6 months. Others have taken much longer because their trajectories were optimized for fuel efficiency rather than speed. The destination stayed the same. The journey changed. Another surprising fact is that the closest planet isn't always the easiest one to reach. At first glance, Mercury seems like it should require the shortest trip. After all, it's the nearest planet to the Sun. But the Sun's immense gravity creates an unexpected challenge. A spacecraft leaving Earth isn't simply falling toward Mercury. It's already traveling around the Sun at nearly 30 kilometers per second. To reach Mercury successfully, it must slow down dramatically. Otherwise, it will race past the planet instead of entering orbit. Ironically, this makes Mercury one of the most difficult planets to visit. NASA's Messenger spacecraft launched in 2004. Instead of flying directly to Mercury, it spent more than 6 years looping around the inner solar system, using multiple gravity assists from Earth, Venus, and Mercury itself before finally entering orbit in 2011. The closest planet demanded one of the longest journeys. Distance alone didn't determine the travel time. Orbital mechanics did. Understanding these principles completely changes the way we think about the solar system. It's not a collection of planets lined up in a row. It's a constantly moving system where every object follows its own path around the Sun. Every successful mission is a result of thousands of calculations balancing gravity, velocity, timing, and fuel. Only after understanding those rules can we answer the question that brought us here. How long does it actually take to reach each planet? The answers are far more surprising than most people expect, because the journey begins with a planet that is closer than Mars, yet often takes even longer to reach. Now that we understand why traveling through the solar system is more complicated than simply pointing a rocket toward another planet, it's time to begin the journey. We'll start with a world that seems like it should be the easiest destination, Mercury. Mercury orbits the Sun at an average distance of just 58 million kilometers. On paper, it looks like the simplest destination in the solar system. In reality, it's one of the most difficult. The problem isn't distance, it's speed. Earth and Mercury are both racing around the Sun, but Mercury travels much faster. A spacecraft leaving Earth must shed a tremendous amount of orbital energy before Mercury's gravity can capture it. Without slowing down, the spacecraft simply flies past the planet. That's exactly why NASA's Messenger mission spent more than 6.5 years reaching Mercury. It wasn't taken the long way by accident. It was carefully using gravity assists from Earth, Venus, and Mercury itself to reduce speed step by step. More recently, the European-Japanese Bepi-Colombo mission launched in 2018 and is expected to arrive at Mercury in late 2026. Again, the journey takes years, not because Mercury is far away, but because orbital mechanics demand patience. The closest planet teaches an important lesson. In space exploration, the shortest distance doesn't always produce the shortest trip. The next destination is Venus. At its closest approach, Venus comes nearer to Earth than any other planet. Depending on where both planets are in their orbits, spacecraft typically arrive in about 4 to 6 months. That makes Venus one of the fastest destinations beyond the Moon. Several Soviet Venera missions reached Venus in less than 5 months. NASA's Magellan spacecraft arrived after approximately 15 months because its mission prioritized a different trajectory. Once again, travel time depends on mission design. Venus also reveals another important truth about planetary exploration. The easiest planet to reach isn't necessarily the easiest to explore. Its atmosphere is nearly 90 times denser than Earth's. Surface temperatures exceed 460 degrees Celsius. making Venus hotter than Mercury despite being farther from the Sun. Reaching Venus is relatively straightforward. Surviving there is an entirely different challenge. Among all the planets, Mars has become humanity's primary destination. Not because it's the closest, not because it's the easiest, but because it's the most realistic place where humans might one day establish a permanent presence. A typical robotic mission to Mars takes about 6 to 9 months. NASA's Perseverance rover completed its journey in just under 7 months. The Curiosity rover required a similar amount of time. Those numbers often surprise people. Mars may appear close in astronomical terms. Yet even with modern rockets, the journey consumes nearly half a year. The reason lies in efficiency. Current missions rarely accelerate at full power from Earth all the way to Mars. Instead, they coast along carefully planned transfer orbits, allowing gravity to do most of the work. That approach dramatically reduces fuel requirements. The trade-off is time. Future propulsion systems may eventually shorten the journey to 3 or 4 months. Some experimental concepts suggest it could become even faster. But with today's technology, patience remains part of every mission to Mars. Between Mars and Jupiter lies the asteroid belt. Movies often portray it as a crowded obstacle course filled with tumbling rocks. Reality is much quieter. The asteroids are separated by enormous distances. A spacecraft can cross the belt without encountering a single object nearby. NASA's Dawn mission proved exactly that. After leaving Earth in 2007, Dawn traveled to the belt before reaching Vesta in 2011 and later Ceres in 2015. The asteroid belt marks something more important than a collection of rocky objects. It represents the point where journeys begin shifting from months to years. Beyond this region, the solar system expands dramatically. Jupiter changes everything. The solar system suddenly becomes much larger. At an average distance of nearly 780 million kilometers from the Sun, Jupiter is no longer an inner planet. It's the gateway to the outer solar system. NASA's Juno spacecraft reached Jupiter in about 5 years. The famous Galileo mission required nearly 6 years after using gravity assist from Venus and Earth. Those long travel times weren't signs of slow spacecraft. They reflected the enormous distances involved. Jupiter is so massive that its gravity influences nearly every mission traveling beyond it. Sometimes spacecraft visit Jupiter not as a destination, but as a slingshot. Voyager, Cassini, New Horizons, each borrowed energy from Jupiter before continuing toward even more distant worlds. In many ways, Jupiter functions like the solar system's greatest gravitational accelerator. Its immense gravity has helped humanity explore places that would otherwise remain out of reach. By the time a spacecraft reaches Jupiter, something remarkable has happened. The inner solar system already feels distant. Earth has become a tiny pale point orbiting a star that now dominates the sky less and less with each passing billion kilometers. And yet, our journey isn't even halfway finished. Beyond Jupiter lie worlds where travel is measured not in months, but in decades. Crossing Jupiter is more than reaching another planet. It's crossing an invisible boundary. The inner solar system is where humanity has spent most of its time exploring. The outer solar system is different. Distances increase dramatically. Sunlight becomes weaker. Communication delays grow longer. And every mission becomes a commitment measured not in months, but in years. Saturn is nearly twice as far from the Sun as Jupiter. That extra distance changes everything. NASA's Cassini spacecraft launched in October 1997. Instead of flying directly to Saturn, it performed gravity assist around Venus, Earth, and Jupiter before finally arriving in July 2004. The journey lasted almost 7 years. Those years weren't spent waiting. Cassini remained busy throughout the mission, collecting valuable observations during every planetary flyby. By the time it entered Saturn's orbit, it had already traveled billions of kilometers. What followed became one of the most successful planetary missions in history. For the next 13 years, Cassini transformed our understanding of Saturn, its magnificent rings, and moons like Titan and Enceladus. Its long journey proved something important. Sometimes reaching a destination takes less time than understanding it. If Saturn feels distant, Uranus belongs to another world entirely. Only one spacecraft has ever visited it, Voyager 2. After launching in 1977, Voyager 2 reached Uranus in January 1986. The trip took almost 9 years, and yet the encounter itself lasted only a matter of days. Everything humanity knows from a close-up perspective of Uranus comes from that single flyby. No orbiter has ever returned. No lander has ever attempted to descend. No rover has ever explored its icy moons. For a planet nearly 4 times wider than Earth, Uranus remains one of the least understood worlds in the solar system. Not because scientists aren't interested, but because getting there is incredibly difficult. A dedicated mission requires decades of planning, billions of dollars, and nearly 10 years of travel before the real science can even begin. Distance shapes exploration as much as technology does. Beyond Uranus lies Neptune, the 8th planet, the last major planet orbiting the Sun. On average, Neptune is about 4.5 billion kilometers from our star. Even sunlight needs more than 4 hours to arrive there. When Voyager 2 flew past Neptune in August 1989, it completed a journey lasting almost 12 years. To this day, it remains the only spacecraft ever to visit the planet. Every detailed image of Neptune you've ever seen, every close-up of its clouds, its giant storms, its moon Triton, all of them came from a spacecraft that spent over a decade crossing the solar system. That fact alone says something remarkable. Humanity has reached Neptune only once. Not because we lack curiosity, but because the journey itself is extraordinarily demanding. By the time Voyager 2 left Neptune behind, it had completed what was once considered nearly impossible. But its mission wasn't over. It kept going, past the planets, past the Kuiper Belt, toward interstellar space. Today, Voyager 2 is more than 20 billion kilometers from Earth. Its radio signals travel for roughly 18 hours before reaching us. Even at the speed of light, communication is no longer immediate. Every command sent to Voyager becomes an exercise in patience. Mission controllers transmit instructions today and wait until tomorrow just to know whether the spacecraft received them. No human conversation has ever been slower. This is where the true scale of the solar system begins to reveal itself. People often picture the planets lined up neatly in textbook illustrations. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The spacing looks almost uniform. It's convenient, easy to understand, and completely misleading. If Earth were placed 1 meter from the Sun, Neptune wouldn't be 8 meters away. It would be roughly 30 meters away. Most classroom diagrams compress the outer solar system so dramatically that our brains never develop an accurate sense of its size. The gap between Mars and Jupiter alone is enormous. The distance from Saturn to Neptune is larger still. As we move farther from the Sun, space doesn't expand gradually. It expands dramatically. This is why traveling beyond our solar system remains one of humanity's greatest challenges. Consider our nearest stellar neighbor, Alpha Centauri. It isn't billions of kilometers away. It's over 4.3 light years from Earth. The fastest spacecraft ever launched, Parker Solar Probe, can reach extraordinary speeds while flying close to the Sun. Even so, at that speed, reaching Alpha Centauri would still require thousands of years. And that's our closest neighboring star. Before humanity dreams of visiting another solar system, there's an important lesson to remember. We're still learning how to explore our own. Looking back, one pattern becomes impossible to ignore. The farther we traveled, the more time each mission demanded. Mercury challenged our understanding of orbital mechanics. Mars tested our ability to land on another world. Jupiter became a gateway for deep space exploration. Saturn revealed the value of long-term scientific missions. Uranus reminded us how much remains unexplored. Neptune marked the edge of humanity's direct experience with the planets. Each destination expanded not only the map of the solar system, but also the limits of what our technology could accomplish. Perhaps the most surprising answer to the question we asked at the beginning isn't measured in months or years. It's measured in perspective. The solar system isn't difficult to cross because our spacecraft are slow. It's difficult because space itself is unimaginably vast. Every mission that reaches another planet is a result of decades of engineering, careful planning, and an extraordinary understanding of physics. The next time someone asks, "How long does it take to reach another planet?" the most honest answer is this: long enough to remind us that our cosmic neighborhood is far larger than everyday experience allows us to imagine. And despite everything we've achieved, our journey has only just begun. For centuries, humanity wondered what lay beyond the horizon. Today, that horizon has moved into space. Every mission to another planet pushes it a little farther. Every discovery reveals another destination. And every journey reminds us of the same truth. The universe isn't getting larger. Our understanding of it is.